So for my number 8, we have the prediction of crossbred calf performance in the dams that are first crossed between two breeds with maternal heterosis, 25 kilograms body weight at weaning at 7 months of age. So we have dams that are first crossed between two breeds. So we know these dams are F1. So we could think of it as an Angus times a Brahman or whatever breeds that you want to think of. It's a purebred on a purebred. These dams are F1s. And then we have our maternal heterosis value. So that would be like one of the constants that you were given in your crossbreeding performance problems. So we're thinking about either maternal heterosis, direct heterosis, and breed average. We know it is not the breed average contribution will be 25 because we know that we're talking about maternal heterosis. Direct heterosis has everything to do with the calves that are born. And since we don't know the breeds of the sire, we have nothing to know about how much heterozygosity we'd see in those offspring. So the answer is not going to be D. It is not correction for maternal differences either, because once again, we're talking about maternal heterosis. So it's either going to be between the two answers that are talking about maternal heterosis. And as we know, the fraction of breed heterozygosity in F1s is 1 or 100%. We get 100% breed heterozygosity in an F1. So that would be like taking our 1 and multiplying by 25. So we know that the maternal heterosis contribution will be 25 kilograms. And even if you didn't know right off the top of your head that F1s have 100% breed heterozygosity, you can make yourself just a little punnet box. It'd be an Angus times a Brahman in this case, and you get 100% of the boxes having breed heterozygosity, so Angus and Brahman. So the correct answer is maternal heterosis contribution of 25 kilograms. Moving on to the calculated relatedness between a pair of animals is based upon pedigree, average, and has a non-zero variance that can be calculated except for. So remember, on some of our relationship problems, we calculated the standard error because the relationships that we calculated were just estimates. But the only one that we know for sure that doesn't have any error associated is that parent-offspring relationship. You know exactly how much is shared between parent and offspring. And that's one of the reasons why when you do calculate the standard error for parent-offspring relationship, you minus that quarter, because there is no question about that quarter between parent and offspring relationship. So that's why it's looking for except for. And so parent-offspring relationships have a zero variance. So rank the importance of heterosis expression in offspring in general for progeny traits prior to separation from dams. So let's just think about that from all the way to from birth to weaning. So prior to separation from dams. So we always talk about maternal heterosis is number one for sure. You get so much performance increase from having maternal heterosis. So answer choice C is not correct, and neither is answer choice D, because maternal heterosis is going to outweigh the direct heterosis that we see. And then we're not going to share between direct and paternal. So answer choice E is not correct, because direct heterosis, you'll get a whole lot more performance increase in these traits compared to paternal heterosis. So direct is going to be over paternal heterosis, so the correct answer choice is A. So we rank number 1 as maternal heterosis. We know how important maternal heterosis is. Then 2 is our direct heterosis, so the heterosis due to that offspring being a crossbred. That's super important when it comes to these traits. And then 3rd, paternal heterosis. Moving on to number 11. An officer of the Beef Improvement Federation asks you, as a graduate of Animal Science Department at Texas A&M University, what is the most important component of beef cow-calf breeding season? Some people may think it's black coat color of calves, but that is not the case. While direct heterosis is important, we know that maternal heterosis is incredibly important for reproductive traits and calf traits pre-weaning. Reproductive traits respond tremendously to heterosis and crossbreeding. So the correct answer choice is A. Paternal heterosis. Well, yes, male libido and seminal traits is important. It is not the most important thing. And once again, you get a lot of increase in performance traits because of maternal heterosis. So that's going to outweigh the direct heterosis.